This is take 2 of my Bedini insanity. This plastic stuff I bought off the internet, but this is clearly, compared to the last thing I showed you with bicycle wheels, this is significantly smaller. Nice plastic frame. In this circular thing there's some weights and 3 magnets equally spaced around here. And then we've got 4 coils around this one. The one at the bottom, this coil down here, is bifilia wound. These 2 are wound with some fairly thick wire, but just single coils. And this top one is a single coil again, but this is a much smaller wire with a lot more turns on it, and this is just a generator coil. So the schematic is the same as before. So we've got an inductor here, and I've now got, as the magnet passes over the inductor, it's opening up the base of this transistor, but I've actually got 3 lots of this circuitry in parallel, one being triggered by they're all being triggered by this coil on the left hand side, but the right hand side coil, which is expelling the magnet and causing the circular motion, is repeated another 2 times. So if you look at the circuit board down here, you'll see there are 3 power transistors all pushing with their individual coils. Now the scope over here, the bottom waveform, this is what's being seen at the base of the transistors. It's a very nasty looking waveform, but there's about 2, 4, nearly 6 volts, 5 and a bit volts worth of trigger opening up the transistors, and this is the output on the generator coil. So here I've got nearly 15 volts, this is 5 volts per division. I've got nearly 15 volts of sort of AC, but again a pretty nasty looking waveform. So if I look at the frequency of that, that's something I wanted to show you. The frequencies up here, we've got some vertical dotted lines which hopefully you can see. So the frequency, the period of this waveform is 208 Hertz. So 208 Hertz, so that means there's a magnet passing that coil 208 times per second. So divide that by 3, because I've got 3 magnets, and then multiply it by 60, then that gives me just over 4,100 revolutions per minute. The generator coil is currently just connected to some LEDs, which hopefully you can see in here. There's 6 LEDs, ultra-bright LEDs, about 15 volts, as I said, on there at the moment. I haven't measured the current consumption yet. The current consumption of the actual driver coil you can see on my bench power supply over here. So we've got 12.1 volts and about 310 milliamps. I'm going to do some more experiments with this to see what the current consumption is likely to be. The only thing I wanted to show you is that the charging battery, which is connected over on my right hand now, if I disconnect that, hopefully you can see that the neon indicators are now very brightly lit. You can also hear that the motor is accelerating because there's no longer any load on it. Now, the one thing that really tells me is that the back EMF coming off these inductors, the fact that it's lighting these neon indicators down here, tells me that there's 90 plus volts available there. In fact, there's probably a lot more. They seem to be lighting very brightly. So, just wanted to show you this. It's pretty. It's a bit noisy. I need to put some oil or something on the bearings of this thing. I'm going to turn it off now so you can see what happens when we switch it off. I thought I'd post this, and then tomorrow, or maybe over the weekend, or when I can be bothered, I'll get the bigger one back down again, and I will do some current measurements and try and figure out what's actually going on here. You can hear the rattle as well. Maybe need to get a bit of glue in there. That's it. Bye.